A group of astrophysicists think they may have just discovered proof of alien life, and what they may have found is something that previously only existed in science fiction. They don't think that they just found one of these things. They think that they found 7, and they're in our own galaxy. This is a Dyson sphere. The idea of these alien megastructures was first mentioned in 1937 by British philosopher and science fiction author Olaf Stapledon in his book called Star Maker, where he described a civilization becoming so advanced they could build impossibly giant structures around an entire star to harness its energy. 23 years later, physicist Freeman Dyson published a paper detailing not only how these alien megastructures would theoretically work, but also how to find them in the universe. This is what a group of astrophysicists working on a project called Project HEUS think they may have found right in our own galactic backyard. So, is this true? Did they really find 7 examples of Dyson spheres? Or did they simply find 7 unexplained phenomena in our galaxy, and these astronomers just want them to be Dyson spheres? Let's talk all things Dyson spheres, and how the idea of them actually being discovered and existing might not be as science fiction as you think. In order to figure out if Dyson spheres exist in the universe, let's start with how any civilization would build one in the first place and, more importantly, how they would get enough material to build one at all. Throughout history, technological advancements have been strongly tied to access to energy. This has been true for all civilizations here on Earth. The more a civilization can create or harness energy, the more advanced that civilization can become. We currently exhibit this on a small scale with 3 major categories: fossil fuels, nuclear energy, and renewable energy. As we have gained greater control over each energy source, we've seen our own civilization progress. If all goes well, and we don't destroy ourselves along the way, humanity will reach a point where we have complete control over our planet's resources. At this point, humanity would have reached the first of 3 levels in something called the Kardashev scale. This scale categorizes civilizations based on what type of control they have over the energy available to them. A Type 1 civilization has complete control over its planet's resources, even being able to manipulate and control the planet's weather patterns and harness things like volcanoes, storms, and earthquakes to convert it all to usable energy. A Type 2 civilization has the ability to control the energy from its own host star. If humanity were to reach this scale, we would easily be able to travel around our own solar system freely to other parts of the galaxy, or even be able to travel to other galaxies with things like warp drives or wormholes. Energy would be so abundant that humanity would no longer be restricted on where we could explore. Finally, a Type 3 civilization has the ability to control the energy from every star in its host galaxy. The Milky Way alone has around 100 billion stars, so imagining what a Type 3 civilization could do with that power is really hard to grasp. Keep in mind, for context, humanity isn't even a Type 1 civilization yet. We're still considered a Type 0. But if you really want to put a number behind it as to where we are, we're about a 0.7 civilization on the Kardashev scale. Now, knowing that, where do Dyson spheres come in with all of this? We would expect to see Type 2 civilizations capable of constructing a Dyson sphere, harnessing all the power available from its host star. There have been multiple proposed versions of Dyson spheres from both astrophysicists and sci-fi authors alike. Some suggest encasing the entire star, gathering 100% of its energy output, although this design would be very vulnerable to destabilization, collisions, and possibly falling into the host star itself. However, the other option would be a Dyson swarm, which involves placing trillions or quadrillions of solar panels all around the star like rings or satellites, capturing energy with those giant solar panels in all directions around the star. No matter which version is built, the amount of material needed to build such a superstructure would be beyond anything that the civilization's planet could provide alone. One solution would be for a civilization to take materials from another planet within its system. If humanity were to do this, the best candidate would be Mercury. I'm not talking about just going there and mining large amounts of materials from Mercury itself. We would need to dismantle and mine nearly the entire planet down to its core in order to have enough material just to build a Dyson swarm around our sun, not even a Dyson sphere. So, how would we go about detecting such giant alien superstructures? Well, that's exactly what Freeman Dyson asked over 60 years ago. He proposed 2 major ways to detect the existence of a Dyson sphere. The first is that if you were observing a star at a point in our galaxy, you would see that star slowly dim and eventually disappear as a Type II civilization built the sphere around the star. The second way would be to detect the infrared light still shining brightly where the star's visible light once was, showing that the star is still there but now only emitting infrared light at a brightness that no other star does naturally. This would be because, while the Dyson sphere is gathering energy from its star, the sphere or swarm itself is heating up and giving off excess heat in the form of infrared light. This is exactly what the group of astrophysicists think that they have detected in our own galaxy. Two different teams conducted separate studies, each using different data and equipment like the Gaia telescope and the WISE telescope, surveying millions of stars and together coming up with 7 candidate stars that may have Dyson spheres surrounding them. But did they actually discover Dyson spheres, or something else entirely? These may just look like little black dots on a piece of paper, but in reality, they're actually pretty strange. Many of the Dyson sphere candidates surveyed by one of the teams are classified as red dwarf stars, one of the smaller and certainly the most abundant types of stars in the universe. These red dwarf stars are sitting anywhere around 500 to 900 light-years away from Earth and are emitting 60 times the amount of infrared light as they should be. The second team surveyed stars of varying sizes, not just red dwarf stars, and some of those stars were even close in size to our own sun. These stars, on average, were a lot further away, around 6,500 light-years from Earth. On top of all that, it was predicted that if a Dyson swarm were to exist around a star, the excess infrared brightness would sit around 25 degrees Celsius. According to these studies, this is exactly what we're seeing. On the surface, it would seem that if these 7 candidates are actually alien superstructures, they wouldn't be Dyson spheres. They would more likely be Dyson swarms, which is that series of satellite-like objects surrounding a star, not fully encompassing the entire star. However, the universe typically doesn't give answers like this so easily. It's always a good idea to approach any potential discoveries with a heavy dose of skepticism. It's really important to remember that any findings in these papers are extremely preliminary. To the credit of both of these papers, they openly admit that natural explanations could sufficiently explain these strange findings. Nonetheless, this whole thing is a great example of one of science's dirty little secrets, the search for signs of intelligent life. That may suggest we are not alone. Space is so crazy. I wish I understood it better. Science as a whole, and probably to the surprise of no one, has a huge communication problem, especially when it comes to space topics. Oftentimes, the subject matter is so complex that scientists simply can't find a way to effectively explain it in an approachable manner. Scientists know very well that if they can't make it approachable, it's not likely that the public will take much of an interest in it. Without public interest, investors and companies funding their research might not find it as valuable or profitable to continue to support their research efforts, sunsetting the hopes and dreams of these research teams doing genuinely important work. But you know what the public does respond to? Aliens and the potential for the discovery of alien life. So these scientists, in this case, astronomers and astrophysicists, will adjust how they present their research to reflect those public interests. The playbook is pretty simple. You make the headline about an alien superstructure, something that will capture the curiosity of sci-fi and non-sci-fi fans alike. In hopes that the research will hit enough publications, make their rounds on social media, and create a public demand for further answers, thus ensuring that companies and investors will continue to fund their research. Now, you may interpret that as all scientific papers are purposefully being turned into clickbait, and while that's sometimes true, that's not really what's happening here. In the instance of these 2 papers about Dyson spheres, the science being conducted is actually good science that's producing genuinely fascinating results and insights into the universe. But researchers know that alien superstructures is a catchier and sexier headline. Think of it as the scientists just trying to put really good cover art on their books. How many incredible books have you read in your life that have terrible cover art? Most people have probably just passed over some of your favorite books at the bookstore for that reason alone, and are simply missing out on endless incredible novels just because the pictures on the cover of the book aren't necessarily as interesting as the next. That's sort of what's going on here. These astrophysicists are trying to give you a pretty dust cover to look at and hope that you will read the content and become interested in the mind-blowing, absolutely awesome realities of the universe on its own. The possible natural explanations of these 7 potential Dyson swarms are great examples of this. For example, all of these could just be hot planetary disks producing extra emissions. The dim visible light signatures could be caused by dust and clouds blocking the star's light, and the infrared signatures could be produced as a result of the same dust and clouds simply heating up. Another example could be that huge collisions are happening in these planetary systems, producing large enough clouds of planetary debris to create these results. Or it could simply be that these stars are naturally behaving in ways that we haven't seen before, and we're getting to see new types of stages in a star's life cycle. All of these are just as likely, if not more so, than the possibility of Dyson spheres or Dyson swarms. Further studies are going to be absolutely required, using something like the James Webb Telescope, in order to be certain about any of these possibilities. In fact, since the original papers have come out about Project HEUS, new studies have already been conducted that have explained 3 of the 7 possible Dyson sphere candidates. A different team of astronomers used the Very Large Array Sky Survey, VLASS, which is an array of radio wave telescopes, and they found through those radio waves that the heat emissions being detected are not coming from the stars themselves in 3 out of the 7 candidates. What does that mean? Well, it means that at least 3 of these are almost certainly not Dyson spheres. They are more likely hot dog galaxies. Wait, nope, not that kind of hot dog, a hot, dust-obscured galaxy. While these are very common phenomena in the universe, they are notoriously difficult to find. A hot dog galaxy in the universe is a quasar with a massive amount of dust swirling around an active black hole in the center, giving off tons of radiation and producing a lot of heat, in turn making the galaxy glow brightly in the infrared. You might be sitting there thinking, well, if hot dog galaxies are known within the astrophysics community, why did they immediately assume Dyson spheres at all? Well, it's likely for 2 reasons. One being what I mentioned earlier, aliens will grab people's attention. The other one is that we've only known about hot dog galaxies for about 14 years. This is pretty new information, and finding 7 hot dog galaxies all at once is extremely rare on its own, so it wasn't immediately assumed to be the explanation. That's not saying that the other 4 candidates aren't Dyson spheres or Dyson swarms, because the truth is we still have absolutely no idea what they are. So all possibilities are welcome to the table. But even if they do turn out to all be hot dog galaxies, that's still really cool. I mean, we're talking about the process of a very rare, ancient active black hole consuming and clearing out a galaxy-sized amount of dust, and we're getting to watch the light signatures of it happening in our very own galaxy. That's crazy. If I'm being honest, black holes, quasars specifically, are far cooler and far more interesting than any other alien topic that you can present to me. All this is sort of my point about this particular story and these particular findings about Dyson spheres. The scientists put forward a more tantalizing version of the results to gain public interest, where I don't think they necessarily had to. Hot dog galaxies are interesting enough on their own and, in my opinion, also have a very attention-grabbing name. In the end, I think the likelihood of any of these candidates turning out to be any alien superstructure is extremely low. Not 0, but just very, very low. Only time will tell. We need a lot more time for astronomers to continue surveys and studies on these objects, and telescopes like the James Webb will go a long way in getting those answers faster. In the meantime, we can all continue to look up at the night sky and dream of what may be out there waiting to be discovered. If you're anything like me, you feel that aliens are abundant in the universe, and one day we will stumble across them. But for now, it doesn't seem that that day has come.